Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 7 video on the chapter of exponents, where I will solve the second test paper number 2 that I have prepared on the chapter of exponents. If you have not watched the previous video part 6, which was where I solved the sample test paper number 1, I highly suggest and request that you watch that video also. It will be a good test for to evaluate your understanding of the concepts of the chapter of exponents. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are visiting my channel for the first time or seeing this video for the first time, I highly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future video. So let's get started with this video. Okay, so I have the sample test paper number 2 on the left hand side, and on the right hand side I will solve the questions. So this is a MCQ test. It has 15 questions, all are MCQ. There are 4 choices for each question, and out of the 4 choices only one choice will be correct. Ideally you should solve this paper in 45 minutes, that is you should take 3 or maximum 4 minutes per question. So in 45 to 1 hour you should complete this test. And before seeing this video, you should try to give the test yourself, solve the problems yourself, and if you are stuck at any problem, and if you cannot solve it after multiple attempts, then you see this video as a reference. So while I will be solving the problem, I will discuss the concepts applied to solve a particular problem, and you can pause the video and take a screenshot of my solution for your future reference. Okay, let's start solving the problems. Problem number 1 is a simplification problem. We have to simplify the given expression. The expression is minus 2 raised to the power 3 multiplied by minus 2 raised to the power 7, and this whole divided by we have 3 multiplied by 4 raised to the power 6. Now in this kind of expressions, always try to evaluate the expressions inside any bracket first, and then you apply the multiplication or division. So we can see that the whole expression is a division of two numbers. The first one is this and the second one is this. Now at least you may not before applying the division, you need not simplify the expression inside the two brackets into a rational number. You may not. You can leave it in the exponential form. That is fine. And after applying the division, you can then do all the cancellation from the exponential terms using the laws of exponents. Okay, so let's see how do we solve it. So first I will so this is equal to, now first of all minus 2 raised to the power 3 will be it will be negative of 2 raised to the power 3. Why? Because the base minus 2 is negative and the power is odd number. The power is 3, it's an odd number. We know that minus x raised to the power m, where x is obviously a non-zero rational number, is equal to negative of x to the power m if m is odd, and this is equal to x to the power m if m is even. So we have this multiplied by again minus 2 raised to the power 7. The power 7 is odd, so this will be a negative of 2 to the power 7. And the expression on the second bracket, inside the second bracket, we need not do anything as of now. We are leaving it as it is. Now this again, so it's a negative of 2 to the power 3 multiplied by negative of 2 to the power 7. The two negative cancels. When two negative when multiplied becomes positive. So we have 2 cube multiplied by 2 to the power 7, and this divided by, we have 3 multiplied by. Now you can convert the 4 to the power 6 into an exponential form with the base 2, since on the left hand side in the dividend of the division operation, the dividend, we have powers of 2. So it's better I convert 4 to the power 6 as powers of 2. So now I will be skipping some steps to save time, because I will show that necessary the calculation that I will be skipping on the right hand side. So 4 to the power 6 is nothing but 4 is 2 square, and this whole to the power 6, and this will be equal to 2 to the power 2 into 6, that is 12. Using the formula that x to the power m, this whole raised to the power n, is equal to x to the power m into n. So this will be 2 to the power 12. So if you just see the solution, you might be it might be a little difficult for you to follow. So that is the reason I'm showing the the calculations that I'm skipping on the right hand side. Now you can do so. Now we can apply the division operator. Now we know that 2 cube, this is 2 cube multiplied by 2 to the power 7. Now division operator, I know, can be replaced with a multiplication operator, and the divisor will get replaced by its reciprocal. So it will be 3 multiplied by 2 to the power 12 and whole inverse. Okay, so because we know that when we divide two rational numbers, x divided by y is nothing but x multiplied by y inverse, multiplicative inverse of y. So this is equal to, now 2 cube multiplied by 2 to the power 7. Now what is 3 multiplied by 2 to the power 12? Its reciprocal. Its reciprocal is nothing but 1 by we know that any rational number, any number, its reciprocal is nothing but 1 by x. Reciprocal of x is 1 by x. So definitely the reciprocal of 3 multiplied by 2 to the power 12 will be 1 by 3 multiplied by 2 to the power 12. Now okay, so now I will so we got 2 cube multiplied by 2 to the power 7 divided by 3 multiplied by 2 to the power 12. Now in the numerator I will simplify that using I will add up the powers. Since the base is 2, it's a product of two exponents, then the base is same, so we'll add up the power. So 2 to the power 11 divided by, I have 2 to the power 12 multiplied by 3. Now this is equal to 2 to the power 11 minus 12 divided by 3. This is equal to 2 to the power minus 1 divided by 3, and this is equal to 1 by 3 multiplied by half. This is equal to 1 by 6. This is equal to 1 by 6. I am getting 1 by 6, but the answer, there is no choice. Let me see if I okay, so 2 to the power 3 multiplied by 2 to the power 7, it will be 2 to the power 10, not 11. So it will be 2 to the power 10, and I will have here 10 minus 12, and this will be 2 to the power minus 2, and I have 2 to the power minus 2 means reciprocal of 2 square, so this will be 1 by 2 square 1 by 2 square. So finally the answer will be 1 by 12. 1 by 12. 1 by 12, and this is equal to 12 to the power minus 1. So this is the value, simplified value, and so the answer is choice B. The answer is choice B. So after completing the question, solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution. Okay, let's do problem number 2. We have to solve for x. An equation is given. The equation given is x by 2 whole raised to the power 5 divided by 4 by x whole raised to the power 5 is equal to 32, and we have to find x. Now as usual, for this kind of problem, the main concept for solving this kind of unknown. Now that unknown could be in the base or it could be in the power. Now if you see that the unknown is, if the unknown, if you see, let's say, if the unknown is in the power, then definitely you have to express both the LHS and the RHS of the equation equality sign, so that the LHS is in exponential form. Both LHS and RHS are in the exponential form with the same base if the power is same. If the unknown is in the power, then you have to make somehow the base same on both sides, and if the unknown is in the base, then somehow you have to make the power same on both sides. Now in this equality sign, I can see the powers, the unknown is in the base, x by 2, that is the base, also 4 by x, it is the base, and I can clearly see that the powers on the left hand side, it is constant, that is 5, and on the right hand side, even though it is not in the exponential form, I can convert it with the base 2. My idea is to make the right hand side in the exponential form so that the power becomes 5, because I can see the power of 5 on the left hand side. Okay, so now what is this? Let's first apply the division operator. We have x by 2 raised to the power 5, and divided by 4 by x raised to the power 5 will be multiplied by whatever the divisor is. In this case, divisor is 4 by x raised to the power 5. We have to raise that. We have to take its inverse, multiplicative inverse of reciprocal. Now the right hand side 32, we know it is 2 to the power 5. This implies, okay, so this implies, now this is x by 2 raised to the power 5 multiplied by 4 by x raised to the power. We have two layers of powers. The first layer is 5, power in the first layer is 5, and the power in the second layer is minus 2. Now whenever I talk about layers of powers, what I mean is that whenever you see something like this, x is a rational number, it is raised to the power m, and again it is raised to the power m, I say that this expression has two layers of power. The power in the first layer is m, and the power in the second layer is n. Okay, so this is nothing but x to the power m into n. We know this from the laws of exponents. So this will be 5 into minus 1, that is minus 5. Okay, now this will be, I have to anyhow convert the LHS, the left hand side, in the exponential form where the power will be 5. So this is x by 2 raised to the power 5 multiplied by 4 by x raised to the power minus 5, means x by 4 raised to the power 5. So the concept that I applied in the last step is x to the power minus m is equal to 1 by x to the power m. Now I can see in the left hand side, it's a product of two exponential terms. and they are, where the first base is x by 2 and the second base is x by 4, but the powers is same. The powers is same. Now I will apply the concept that x to the power m multiplied by y to the power m is equal to x into y whole raised to the power m. So this becomes x by 2 multiplied by x by 4 whole raised to the power 5 is equal to 2 to the power 5. Now this becomes x by 2 multiplied by x by 4 is x square by 8. This whole raised to the power 5 is equal to 2 to the power 5. Now I can see the power is same. The the LHS and RHS of the equality sign, both are exponential terms where the power is same. So we can equate the base, because we know that if x to the power m is equal to y to the power m, we can say this implies that x is equal to y. And another concept is that if x to the power m is equal to x to the power n, the base is same but the powers are different, we can say that the powers will be equal, m equals to n. Okay. So in this problem we will get the base will be same, x square by 8 equals to 2. This implies, by doing cross multiplication, we know that x square will be 2 into 8 equals to 16. So this implies x will be equal to square root of 16, that is 4. So x is 4. So the correct choice is C. Correct choice is C. You can take a screenshot of the solution of this problem. Okay, let's do problem number 3. Problem number 3 is that says which of the following is not the reciprocal of 2 by 3 raised to the power 4. Okay, let's find out what is reciprocal or multiplicative inverse of 2 by 3 raised to the power 4. By notation is that reciprocal of any, we know that reciprocal of any non-zero rational number x is by notation is x to the power minus 1 and its value is 1 by x. So reciprocal of 2 by 3 raised to the power 4 is 2 by 3 raised to the power 4. This is the given number and we have to raise this whole to the power minus 1. Now this is equal to, we can see there are two layers of powers. 4 is the first layer of power and minus 1 is the second layer of power. So this will be, the power gets multiplied. So this is equal to 2 by 3 raised to the power will be 4 into minus 1, that is minus 4. Now you have to, depending on what choices, depending on the values in the choices given, you have to see how will you represent or express the reciprocal. So this is the reciprocal in the, so now if you see the choice A is not, definitely not matching with our result. This is the reciprocal and choice A is completely different because choice A also has the power minus 4 but the base is 3 by 2. We need a power of minus 4 and base 2 by 3, which is definitely the choice C. So choice C is the correct choice. Oh sorry, which of the following is not the reciprocal? Sorry, I'm extremely sorry. We have to choose the choice which is not the reciprocal. Okay, so then A, what is A? What is A? The choice A is 3 by 2 raised to the power minus 4, which is definitely not equal to 2 by 3 raised to the power minus 4. So right away we can say that the answer will be choice A, because we have to select the choice which is not the reciprocal of the given number. Now for clarity, you can also check that 3 by 2 3 by oh sorry, my mistake, the choices A and B are same. Choices C and B are same, so anyway it's my mistake. Anyway, so this is not also the is also not a reciprocal of 2 by 3 by 4. Wait a minute, is not the reciprocal of 2 by 3 over 4. 2 by 3, reciprocal of 2 by 3 raised to the power 4 is definitely 2 by 3 raised to the power minus 4. Okay, what is B? Oh, A and B are same choice. So okay, so there is a mistake. A is not a reciprocal, so A should be the correct choice, but we can see that the value given in choice B, this is also not a reciprocal, so B will also be a correct choice. But anyway, that's my mistake. The choice B, I guess, should be different. I might have copied wrongly. And what choice C? Let's see what is choice C. Choice C is 2 by 3 raised to the power minus 4. This is correct. This is the correct reciprocal. And choice D, this is a correct reciprocal, this is a wrong reciprocal, and this is also wrong reciprocal. And choice D, 3 to the power 4 divided by 4 to the power 4, this is equal to 3 by 2 raised to the power 4. This is equal to, I can from here what I can do is that I can reverse. I can take the reciprocal of the base, and also the power I can take the negative. So this is also the reciprocal. So choice A and B should be both applies. The choice A and B, they are not the reciprocal of the given number. So I don't know, I might have wrongly copied the choice B. Choice B should have been something else. Anyway, so there was a mistake in this problem, in the choices, but I hope you got the idea. Let's solve problem number 4. Problem number 4 is also a equation we have to solve. Okay, so what is it saying? It is saying that if minus 4 raised to the power minus m is equal to 4 raised to the power m whole raised to the power minus 1, then which of the following is true? Then which of the following is true? Okay. So minus 4. The right hand side, you can see that m greater than 0. Now in the left hand side, the base is negative. The base is negative, but on the now this is equal to LHS, RHS of the given equation, RHS is equal to 4 to the power m whole raised to the power minus 1. This is nothing but, we can write it as 4 to the power m into minus 1, that is 4 to the power minus m, because from the formula that x to the power m whole raised to the power n is equal to x to the power m into n. So 4 raised to the power m and that whole raised to the power minus 1 is equal to 4 raised to the power m into minus 1, which is minus m. Okay, now so we are getting minus 4 whole raised to the power minus m is equal to 4 raised to the power minus m. Now we can see the powers are same. The powers, both the powers minus 4 minus m are same, but the bases are different. One is negative of the other. So this will only be true. This will only be true only if m is even. M is even, because we know m is even. Only when m is even, this will be true, because we know that as minus 4 minus 4 to the power, we know that minus x whole raised to the power m is equal to x to the power m if m is even. If n is even, meaning that it could be 0, it could be even into positive even integers, or it could be negative even integers. Now it has to be even. It could be 0 or positive even integer or negative even integer. It does not matter whether it is positive or negative. It should be even integer including 0. So if you compare this result from this result, we can clearly say that not this will imply, if we have minus 4 raised to the power minus m is equal to 4 raised to the power minus m, this will imply that minus m is even integer. Minus m is even integer. And when can minus m, when will minus m will be an even integer? When m will be an even integer. So option A says that m greater than 0, but m greater than 0 means that it can also be positive. But if m is positive, this equation will not hold, because we can clearly see that m has to be an even integer. I mean, minus m has to be an even integer. So this implies, if minus m is an even integer, this will also imply m will also be have to be an even integer. So m has to be an even integer. Clearly we can see that m has to be an even integer. It cannot be just m greater than 0 or m less than 0, or m is odd. Definitely it will not work. M has to be an even integer. So the correct choice is D. We know this result on the right hand side. Minus x raised to the power m, it will be equal to x to the power m if m, the power m, is an even integer. But when it says that m is an even integer, it could be positive even integer, it could be negative even integer, or even it could be 0. So if we have something like minus 4 raised to the power minus m is equal to 4 raised to the power minus m, this will clearly say, we can clearly say that minus m has to be an even integer. Like minus m could be 0, or it could be positive even integer, or it could be negative even integer. It cannot be odd integer. And the choice of m greater than 0 and m less than 0, they do not say that m is even. So the only correct choice is D. Okay. Let's do problem number 5. If this expression is the multiplicative inverse of p by q square, then the value of p minus q is, okay. So it is given that this expression 1 raised to the power minus 2 plus 2 to the power minus 2 plus 3 to the power minus 2, if this is the multiplicative inverse of p by q raised to the power 2. So multiplicative inverse of p by q square, its multiplicative inverse is this. So we have this equation from the given problem statement. From here we have to find what will be p minus q. Okay. So let's simplify the LHS. So LHS is 1 raised to the power minus 2 means 1 by 1 square. Similarly, we have 1 by 2 square plus 1 by 3 square. This is equal to p by, so this will be equal to p by q whole raised to the power 2 into minus 1, that is minus 2. So this implies what will be this? This is 1 plus 1 by 4 plus 1 by 9 is equal to p by q raised to the power minus 2. Now this implies what will be this? This will be 36 plus 9 plus 4 divided by 36 equal to p by q raised to the power minus 2. So this implies 49 by 36 is equal to p by q raised to the power minus 2. I can write okay, yes. Now 49, now we can see equality of two terms where the right hand side is an exponential term, and you can also see that the left hand side term is a rational term, but we can see it can be expressed in exponential form because 49 is 7 square and 36 is also 6 square. So this is equal to p by q raised to the power minus 2. Now this implies 7 square by 6 square, I can write it as 7 by 6 whole square or raised to the power 2 is equal to, now p by q minus 2, p by q we have raised to the power minus 2. Now we have to find somehow p by q. The powers, we have to make the power same. The unknown is in the base, so definitely somehow we have to make the powers equal. So p by q, it is raised to the power minus 2. I can write it as q by p raised to the power 2. How come? X by y raised to the power minus m can be written as, I can make the power positive with the same value. It is minus m, power is minus m, I can make the power m and take the reciprocal of the base, that is, this is equal to y by x raised to the power m. Okay, so now I have 7 by 6 raised to the power 2 is equal to q by p raised to the power 2. So we can clearly say that 7 by 6 is equal to q by p. This clearly says that q equals to 7 and p equals to 6. So this implies p minus q is equal to 6 minus 7. This is equal to minus 1. So my minus 1 is the value of p minus q. So the correct choice is B. Okay, let's solve question number 6. Simplify. We are again given we have to simplify. We have to simplify. It is given minus 2 by 3 whole raised to the power minus 2, and this again whole raised to the power 3 multiplied by 1 by 3 raised to the power minus 4 multiplied by 3 raised to the power minus 1 multiplied by 1 by 6. Okay, so let's do it step by step. Okay, so the first bracket, the value inside the first bracket, Let's evaluate this thing first. This will be minus 2 by 3 raised to the power minus 2 into minus 2 into 3, that is minus 6. Applying the concept that x to the power m, x to the power m, this whole raised to the power n is equal to x to the power m and n. In this problem, the x was minus 2 by 3 and m was minus 2 and n was 3. So the first term in the product, we are having a product of 4 terms, and the first term becomes minus 2 by 3 raised to the power minus 6, and we have 1 by 3 raised to the power minus 4. This is nothing but if you want to make the power positive, minus 4 to 4, this will be 3 raised to the power 4, because we know that x raised to the power minus m is equal to 1 by x raised to the power m, and we have 3 raised to the power minus 1, let it be, and we have 1 by 6. So this is equal to now minus 2 by 3 raised to the power minus 6, we can write it as 3 by 2 raised to the 3 by minus 2 raised to the power 6 multiplied by 3 by 3 4 multiplied by 3 raised to the power minus 1 and 1 by 6. Now you can 3 by minus 2, you can in the base rational number 3 by minus 2, you can make the denominator positive, even though it is not required. You can right away break the exponential form, that is 3 by minus 2 whole raised to the power 6 in the rational form as 3 to the power 6 divided by minus 2 raised to the power 6, and we have 3 to the power 4 multiplied by 3 to the power minus 1 divided by 1 by 6. Now this is equal to, we have, let's combine all the exponential terms with base 3. We will add up all the powers. So it becomes 3 raised to the power 6 plus 4 minus 1. And we have, so minus 2 raised to the power 6. The base is negative, but the power 6 is even. So this will be 2 to the power 6. And we have multiplied by 1 by 6. So this is equal to 3 to the power 9, 3 to the power 9, and divided by 2 to the power 6 multiplied by 1 by 6 is 2 multiplied by 3. So then this becomes 3 to the power 9 divided by 3 multiplied by 1 by 2 multiplied by 2 to the power 6. This is equal to 3 multiplied by 8 divided by 2 multiplied by 7. So this is equal to 3 multiplied by 8, depending on in what format the choices are given, you have to manipulate the final result. So we can write it as multiplied by 1 by 2 to the power 7 means 2 to the power minus 7. So the three to the power 8. Okay, so we are having this now 3 to the power 8. Now which choice has 3 to the power 8? Definitely the choice D. The choice D is only is having 3 to the power 8, because now it's a little different from what we have, but let's see what if we can, what exactly it is. It is given that this. Now this is equal to, if you break 3 by 2 raised to the power 8, this will be 3 raised to the power 8 divided by 2 raised to the power 8 multiplied by 2. Now this is equal to 3 raised to the power 8 divided by the numerator, the 2 in the numerator will cancel, 1 2 in the denominator, so this will become 2 raised to the power 7. So this is equal to 3 to the power 8 multiplied by 2 to the power minus 7. 1 by 2 to the power 7 is equal to 2 to the power minus 7. So D is the correct choice. D is the correct choice. Okay, let's solve problem number 7. We have to solve for x, where the equation given is 5 to the power x multiplied by 5 to the power 3 multiplied by 5 to the power minus 2 divided by 5 to the power minus 5 equals to 5 to the power plus 12. So this is pretty straightforward. We have to just, using the laws of exponents, we have to manipulate and convert the LHS to a single exponential term. Now in the numerator we see 5 raised to the power x multiplied by 5 to the power 3 multiplied by 5 to the power minus 2. We have same base, the powers are different, so the powers will add up. So we will have 5 to the power x plus 3 minus 2 in the numerator. In the denominator we have 5 to the power minus 5. This is equal to 5 to the power 12. So this implies, if we simplify the numerator on the left hand side, this is 5 raised to the power x plus 1 divided by 5 raised to the power minus 5 equals 5 raised to the power 12. Now this implies this will be 5. So using the laws of exponents, x to the power m divided by x to the power n is equal to x to the power m minus n. We get this will be x plus 1 minus of minus 5, and this is equal to 5 raised to the power 12. So this is equal to 5 raised to the power x plus 1 plus 5, that is x plus 6 is equal to 5 raised to the power 12. So we can see on both sides, the left hand side and the right hand side, they are both exponential terms with the same base. Base is 5 on both sides. So we can equate the powers. So this will become x plus 6 equals 12. This implies x equals to 12 minus 6 equals 6. So x is 6. So the choice will be B. Okay, let's do problem number 8. Problem number 8. So this is a simplification problem. We have to simplify. Twice of d square multiplied by e raised to the power minus 1 and this whole raised to the power cube multiplied by d cube by e this whole raised to the power minus 2. Okay, now how do you do this? Now please note that we know this, that if x, y, a product of two rational, x and y are two non-zero rational numbers, their product, and if their product is raised to the power m, we can split this. This will be equal to x to the power m multiplied by y to the power m. So using this concept on the right hand side, we can say that the LHS will be 2 to the power cube multiplied by d square to the power cube multiplied by e to the power minus 1 whole raised to the power cube, and this multiplied by, I can say that d cube by e raised to the power minus 2 is e by d cube raised to the power square. So this is equal to 2 cube multiplied by d square raised to the power 3 is d to the power 6 multiplied by e raised to the reciprocal of e, that is e to the power minus 1, and that whole raised to the power 3 is e to the power minus 3 multiplied by e by d cube whole raised to the power square. If we express that in rational numbers, but it will become e square by d cube square. So this is equal to 2 cube is 8. We have d6, and if we merge the e to the power minus 3 and multiplied by e square, this will be e to the power minus 3 plus 2, and we have 1 by d cube raised to the power 2 is d to the power 6. So d to the power 6, d to the power 6 cancels out, and we have 8 multiplied by e to the power minus 1. So this is 8 e to the power minus 1. This should be the value, simplified value, and so the correct choice is C. C is the correct choice. Okay, let's do problem number 9. 9, we have to find the standard form of the given number. Now the given number is is looking complex. We have some exponential terms in the numerator and some exponential terms in the denominator. So the concept is we have to find the standard form. Okay, so we have 4 to the power minus 5 multiplied by 10 to the power 6 multiplied by 625 divided by 40 raised to the power minus 8 multiplied by 5 square multiplied by 4 square. Now in standard form, you know that the standard form is x multiplied by 10 to the power y, where x is greater than equals to that x is a rational number or decimal number greater than equals to 1 but less than 10, and y is a non-zero integer. It could be positive or it could be negative. It is an integer. This is the standard form. So in this kind of problem, if wherever you see some powers of 10, leave it. Don't try to group all the powers of 10 into a single. Try to merge all the powers of 10 from the numerator as well as from the denominator as a single power of 10, because we will need it. The final standard form must have this 10 to the power y factor. So in the numerator, I have 4 to the power minus 5, that is fine. I will leave 10 to the power 6 as it is. 625, I will convert it as a power of 5, because I see in the numerator I have 5 square. So 625 is 25 square, is 25 square. Now the denominator 40 raised to the power minus 8. Now 40, you can see that 40 can be written as 4 into 10. So this is 4 into 10 whole raised to the power minus 8, and we have 5 square multiplied by 4 square. Okay, now this is equal to 4. Now so this is equal to 4 raised to the power minus 5 multiplied by 10 to the power 6. 25 square, you can say it is 5 square and whole raised to the power 2. Now 4 into 10 whole raised to the power minus 10 can be written as 4 to the power minus 8 multiplied by 10 to the power minus 8. That is x into y raised to the power m is equal to x to the power m multiplied by y to the power m. And we have 5 square and we have 4 square. Now we will eventually merge all the powers of 4 and all the powers of 5 and all the powers of 10 into a single exponential terms with the bases 4, 5 and 10. So if I merge all the, I can see now, okay, so this is 4 to the power minus 5 multiplied by, I can group the powers of 10 like this, 10 to the power minus 8, and I will I have 4 to the power minus 8 multiplied by 4 square, and I have 5 square whole raised to the power 2 is 5 to the power 4, and I have divided by 5 square. So now I will applying the law x to the power m divided by x to the power n is equal to x to the power m minus n. I will apply these laws of exponent. So this becomes now 4 to the power minus 5, this is divided by 4 to the power minus 8 plus 2, that is minus 6, and we have here 10 to the power 6 minus 8, and we have 5 raised to the power 4 minus 2. This is equal to now 4 minus 5 minus of minus 6 multiplied by 5 square multiplied by 10 to the power 2. This is equal to 4 raised to the power minus 5 plus 6, 4 multiplied by 5 square multiplied by 10 square. This is equal to 4 multiplied by 25 multiplied by 10 square. This is equal to 100 multiplied by 10 square. This is equal to 10 square multiplied by 10 square. This is equal to 10 to the power 4. So the final value of the given expression is 10 to the power 4, and we can always write it as 1 multiplied by 10 to the power 4, which is in correct standard form. So the correct choice is A. The correct choice is A. You have to be very patient, and you have to apply the laws correctly and systematically, step by step, slowly. Don't be in a hurry. Step by step, do it step by step, but do not make any mistake in applying the laws. Okay, let's do problem number 10. This is also we have to solve for x, which is in the power. Okay, so now this is a little bit might be a little complex expression. On the left hand side, this is 4. This 4 is raised to the power root x, and this root x is also raised to the power root x, is equals to given 256. Now if it's not clear what exactly is happening on the left hand side, this is nothing but 4 raised to the power, the power is root x, which is raised to the power root x. I hope this is correct. I am correctly interpreting the question. It is yes, I think this is correct. Now, okay, so this is what is happening going on. So I have on the left hand side, it is an exponential form with the basis 4, and what is the power? What is the power? The power is again an exponential term, which is root x raised to the power root x. Now definitely, to solve this kind of problem, the right hand side I can see the left hand side is an exponential term with the base 4. So the right hand side I have to convert it, express it as an exponential term with base 4, and I know that 256 will be 4 raised to the power how much? 256 is 16 into 16 is 256, I guess. 96 and 16, yes, 256. So 4 raised to the power 4 raised to the power 4, we have 256. Now, so we have, from this we can see that the equality sign, both the LHS and the RHS are in exponential form, having the same base 4. So from this we can say that the powers of the two exponential term from both sides should be equal, which means root x raised to the power root x should be equal to 4. Now the left hand side now, obviously the 4 you can express it in the exponential form as 2 to the power 2, and you can clearly see that the left hand side, the base and the power is same, and the base is root x and the power is also root x, and on the right hand side also I can see the base is 2 and the power is 2. So this clearly implies that root x has to be equal to 2. If root x is equal to 2, I have to find x, I have to solve for x. If I square both sides, I can say that this will be equal to 2 square. This implies root x square is equal to, I hope you have done roots and cube roots. So root x, the square of root x is x. This is equal to 4. So the answer is choice C. C is the choice. This was a little a bit tricky and good question. Okay, let's do problem number 11. It is given P by Q. P by Q is given to be 2 by 3 raised to the power 3, that is cube, divided by 3 by 2 raised to the power minus 3. Then the value of P by Q raised to the power minus 10. We have to find the value of P by Q raised to the power minus 10. So for that we have to find what is P by Q. Okay, so first let's simplify what is P by Q. So we have P by Q this. So this is equal to 2 by 3 raised to the power cube divided by, now 3 by 2 raised to the power minus 3 means 2 by 3 raised to the power 3. Now I will rewrite the division operator using the multiplication operator as this will be multiplied by the reciprocal of the divisor. The divisor is 2 by 3 raised to the power 3. So its divisor, its reciprocal will be 2 by 3 raised to the power 3 whole raised to the power minus 1. So this is equal to 2 by 3 cube multiplied by 2 by 3 raised to the power minus 3. Okay, this is equal to 2 by 3 raised to the power cube multiplied by 3 by 2 raised to the power 3. Okay, now you can convert the exponential terms in the rational form, and it will be 2 cube divided 2 by 3 raised to the power cube is 2 cube divided by 3 cube. Similarly, 3 by 2 raised to the power cube is 3 cube divided by 2 cube, and we can see all gets cancels out. So this is equal to 1. P by Q is equal to 1. P by Q is equal to 1. So this implies P by Q raised to the power minus 10 is equal to 1 raised to the power minus 10 is equal to 1. Always remember that 1 raised to the power any integer is always equals to 1. 1 raised to the power m, where is m is any integer, positive, negative or 0, is always equal to 1. So the value of P by Q raised to the power minus 10 is 1. So the choice is A. Okay, let's do problem number 12. By what number should minus 24 raised to the power minus 1 be divided to give the quotient as 3 raised to the power minus 1? Okay, it is asking by what number we should multiply this. This is nothing but reciprocal of minus 24. Should be divided, what number this, by what number this should be divided. Let's say the number be x. This will quotient, it will give a quotient of 3 raised to the power minus 1, which means reciprocal of 3. Okay, so this implies Now what is minus 24? Reciprocal of minus 24, it is 1 by minus 24. And what divided by x means multiplied by reciprocal of x, that is 1 by x, is equal to reciprocal of 3. 3 raised to the power minus 1 means reciprocal of 3, that is 1 by 3. So this implies that 1 by minus 24, you can convert it into standard form, that is make the denominator positive, and it becomes minus 1 by 24 multiplied by 1 by x equals to 1 by 3. From here, how do we get x? First, let's find out what is 1 by x. 1 by x will be equal to minus 1 by 24, its multiplicative inverse multiplied by 1 by 3. How come? You must be knowing that a, if you have something, some equation with an unknown variable x, x is equal to b, sorry, this will imply x is equal to the coefficient of x, you take the multiplicative inverse of that coefficient multiplied by the right hand side. This is nothing but b by a. Simply you are dividing the right hand side with the coefficient of x. So here to find 1 by x, I am dividing 1 by 3 by the coefficient of x, that is minus 1 by 24. So we have this. You could have alternatively written like 1 by x will be 1 by 3 divided by minus 1 by 24. Now this is equal to 1 by 3 multiplied by reciprocal of minus 1 by 24, that is 424 by minus 1. Because we know that x divided by y, where x and y are non-zero, y is specially non-zero rational number, this is equal to x multiplied by the reciprocal of y. This is nothing but x divided by y. So this is equal to 1 by 3 multiplied by, now 24 by minus 1, let's make it into standard form. The rational number 24 by minus 1 will be equal to minus 24 by 1. Now I cancel minus 24 by 3, this becomes minus 8. So 1 by x, we got 1 by x is equal to minus 8. This implies we have to solve for x. No, okay, so we have to find the number which should be divided by. Okay, so 1 by x is minus 8. This implies x is equal to 1 by minus 8. This is equal to minus 1 by 8. Minus 1 by 8. So x is minus 1 by 8. That is the number which should be dividing the minus 24 raised to the power minus 1 to give the quotient 3 raised to the power minus 1. So the correct choice is D. D is the correct choice. Okay, let's do problem number 13. Okay, so we are given some equation, we have to find k. Fine. It is given x to the power m multiplied by x to the power n divided by x to the power p. This whole raised to the power q is equal to x to the power k. Certainly we can see that on both sides we have some exponential terms where all the terms are having base equal to 6 x. So definitely to find k, which is on the, we have to find k which is on the power on the right hand side, we have to convert the left hand side as a single exponential term with the base x. So let's do that. Let's simplify the LHS. Now x to the power m multiplied by x to the power n, using the basic laws of exponents, we get x to the power m plus n divided by x to the power p whole raised to the power q is equal to x to the power k. This implies, now again x raised to the power m plus 1, m plus n divided by x to the power p will become x m plus n minus p, and this whole raised to the power q is equal to x to the power k. So again this implies this will be, so we over here we applied the formula x to the power m multiplied by x to the power n is equal to x to the power m plus n, and over here we applied the formula x to the power m divided by x to the power n is equal to x to the power m minus n, and over here we will apply the formula x to the power m whole raised to the power n is equal to x to the power m into n. So this will become q into m plus n minus p equals to x to the power k. Now we see both the terms LHS and RHS are in exponential form with the same base x. So we will equate the powers. So this will become q into q multiplied by m plus n minus p is equal to k. So k is q multiplied by m plus n minus p. So the correct choice is B. Okay, let's do question number 14. Question number 14 says, study the following two statements and select the correct choice. We are given two statements, S1 and S2. What is S1 saying? S1 is the larger number between 9 to the power 6 and 2 to the power 18 is 2 to the power 18. Okay. Now, how do we know which is larger between two numbers in exponential form, 9 to the power 6 and 2 to the power 18? Now, if you can, so if you are given to exponential form, exponential numbers, if you can somehow express both the exponential numbers in exponential form having the same power, then you can compare the base. Or if you can express both the exponential terms, exponential numbers having the same base, then you can compare the powers. Depending on the powers, if the base is same, then you compare the power. Whichever is the larger power, that number will be more higher, larger. And if the power is same, then the exponential term with the larger base will be the larger. Now we can see that both base and powers are different. We have to somehow figure it out how to convert them to have the same base or same power. Now we cannot, I don't see we can make the base same, because one is 9 and one is 2. And there is no common factor of 9 and 2, so base cannot be same. So somehow we have to make the power same. We have to make the power same. 9 to the power 6. Now can we convert 2 to the power 18 having, how do we convert to have the power as 6? Now we know 2 to the power 18 is 6 into 3. 2 to the power 6 into 3. Now 2 to the power 6 into 3, if I want to convert this whole exponential term with the power only 6, I can do 2 to the power 3 whole raised to the power 6, because I know if I have something like x to the power m into n, I can always write it as x to the power m whole raised to the power n, or I can also write it as x to the power n whole raised to the power m. So now what 2 to the power 18 we have expressed this as 2 cube whole raised to the power 6. Now what is 2 cube? 8 to the power 6. Now we see that the numbers are 9 to the power 16, 9 to the power 6 and 8 to the power 6. So powers are same, as 9 greater than 8, this will imply 9 to the power 6 is greater than 8 to the power 6. So this implies 9 to the power 6 greater than 2 to the power 18. And it is saying, the statement 1 is saying that the larger number between is 2 to the power 18. So S1 is false. is a false statement, because we can see the larger number is 9 to the power 6. S1 is false. Let's see what is S2. The value of is 2 to the okay, some expression is given which is 1 raised to the power 0, 2 raised to the power 0 plus 3 raised to the power 0 multiplied by 6 raised to the power minus 1. It is saying that this value is 2 to the power minus 1, that is 1 by 2. Let's see. This value is, now we know that any exponential term having the power 0, where the base is some non-zero rational number and the power is 0, it is always 1. So we have 1 plus 1 plus 1 and multiplied by 6 raised to the power minus 1 is reciprocal of 6, that is 1 by 6. 1 plus 1 plus 1 is 3, so this is 3 by 6, this is 1 by 2, and this is 2 raised to the power minus 1. So S2 is a true statement. Now we have to select the correct choice. Choice A is saying both S1 and S2 are true. No, only only S2 is true. So this means the choices are given wrong. I mean, there are S3. In the choice D, it is saying S1 is false and S3 is true. It should be choice D. Actually, the answer is choice D, but I have wrongly written it. Choice D should be S1 is false and S2 is true. Choice C is S1 is true and S2 is false. No, that is wrong. Choice B is both are false and choice A is both are true. No, choice D should be correct choice, but it is written incorrectly. It should be S1 is false and S2 is true. S2 is true. Okay. Can you see the question number 15? Oh no, you cannot see the question number 15. So how do I? You cannot see the question number. Let me see if I can do something. Okay, now it should be able to see question number 15. Okay, let's do question number 15. The value of, okay, so it's a simplification problem. The value of 1 by 4 square minus 1 by 4 cube, this whole multiplied by 2 to the power 6. Now in this problem, you might be you might be simplifying the value inside the square bracket first, and then you will multiply it by 2 to the power 6. But when you will try to simplify the division of the two exponents, it will take some time. You can see that in the inside the bracket, the exponential terms, the division of it's a division of two exponential terms, and both the exponential terms, the base are 1 by 4, and it's 1 by 4. Now 4 you can always express as a power of 2. So if you observe that, if you, instead of simplifying the division inside the bracket first, if you apply the distributive law of multiplication over subtraction, you will be able to solve it more quickly. That is, I will distribute the multiplication over subtraction and it will become 1 by 4 square multiplied by 2 to the power 6 minus 1 by 4 cube multiplied by 2 to the power 6. Now what is 1 by 4? Now okay, now I will so 1 by 4 so 1 by 4 raised to the power 2, I will write 1 by 4 by 4 I will write at 2 square. So this is 1 by 2 square raised to the power 2 multiplied by 2 to the power 6 minus, similarly I will write 2 square raised to the power cube multiplied by 2 to the power 6. Now if I will break the exponential term, that is 1 by 2 square whole raised to the power 2 as 1 square divided by 2 square whole raised to the power square, and I have 2 to the power 6 minus, I will break 1 by 2 square whole raised to the power 3 in the rational form as 1 cube divided by 2 square whole raised to the power cube and I have multiplied by 2 to the power 6. Now this becomes 2 to the power 6 and divided by 2 to the power 4 minus I have 2 to the power 6 divided by 2 to the power 6. So this becomes 2 to the power square 6 minus 4 minus 2 to the power 6 by 2 to the power 6 is 1. So this becomes 4 minus 1 equals to 3. So this way, if you distribute the multiplication over subtraction, you will see that you will get the computation will be simpler. So the correct choice is C. So this brings to an end of solving the sample test paper number 2. I hope these set of problems will be a good practice to evaluate your understanding of the concepts of exponents, its laws, and all the concepts that we have discussed from the textbook of author R.S. Aggarwal, that is numbers in standard form, large numbers, very small numbers in the standard forms, and the basics of exponents and its laws. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future video. So with the 2 test papers, I have completed the chapter of exponents, and then in the next video I will start the next chapter, which I don't know, maybe it's square roots. Whatever the next chapter is, I will start the next chapter. So thanks for watching, and until the next video, take care and bye.